Assalamu alaikum wa rahmatullahi wa barakatuh. Bismillahirrahmanirrahim. I think we are done with what we call explicit feedback, and we discussed one method, which is Rocio's method. Of course, there are other methods in other retrieval models, but with vector space model, Rocio's is one of the very common methods for relevance feedback. And we also discussed why or what problems we can, what challenges we can face when we use explicit feedback. One of them is that the user actually tends to be lazy in giving feedback. So it might look a nice idea, but it might not be practical. Okay, at least you should not expect much feedback from the user, which is needed for that method to be really effective. So, any ideas of how we can solve this problem? Yes. We should
estimate how much time a user spent on a particular document so that we can judge whether it was relevant to the document.
Okay. So you are saying that instead of asking the user for explicit feedback, we can get instead implicit feedback. Okay, so you started to think about that now, right? By looking at the document, that might be some form of feedback, right? We call that implicit feedback because the user actually didn't give explicit feedback, but with the with the interaction of the user, with observing the user interaction with the system, we can get some form of feedback. But at the other extreme, we'll get to implicit feedback later, inshallah, today. But at the other extreme, we mentioned explicit feedback. Okay, what is the opposite other extreme? Yes. Yes, so that's the assuming no relevant at all, no relevance feedback at all, okay? Which we call it blind relevance feedback. So you will not get explicitly any feedback from the system. You will not even get implicit feedback, but you will assume that there is a feedback. Okay, so we'll see how right away. Okay, so this is called pseudo relevance feedback or blind relevance feedback. So actually, you don't get a feedback from the system, from the user. Okay, but you get automated feedback from the system. How is that? You will retrieve first, of course, the user will give you a query, right? So we assume that the user will give an initial query. Then the system will retrieve a ranked list of results. Okay, you again look at the slide and you are not with me. So please be with me. The slide will be with you, inshallah. Okay, and you will see the slide very soon. Okay? Be with me. Well, that's the problem. Well, this is the problem. When you try to do that, you will really lose me. You will pay attention to what is written. Okay? And you will not hear me. Probably you will not do both. It's really hard to read and also understand what I'm saying. Okay? You will have that so much time. Okay? But probably you will have me also in the recorded video. Now, okay, but anyway, you are with me now live, so please be with me. So what is the idea of blind relevance feedback? The user will issue a query, okay? The system will the user will enter the query, the system will retrieve results based on that query, okay? Now, we will not ask the user for giving any feedback. Instead, the system will assume that the top retrieved documents are relevant. Just an assumption. Of course, this assumption might be very bad for some queries, might be very good for some queries. Okay? But that's the assumption in blind relevance feedback. That the system will assume that this top 1 or 2 or whatever number retrieved documents are relevant, and then continue as if we got explicit feedback. Okay, so that's the idea. So we'll not ask the user for explicit feedback. We'll assume the explicit feedback on the top retrieved documents. Okay? Yes. No, there's no clicking. There's nothing. We're not. Okay. So maybe you missed that from my description of the way that blind relevance feedback will work. Actually, we will not show the user the initial documents in the first place. Yeah, the initial ranked list will not be presented to the user. The initial ranked list will just be used to simulate the feedback, to expand the query, and then we will get the modified query, then we will get the new ranked list, and this is the list that will be presented now to the user. The results of the modified query, exactly. Okay, so the user will not be in between at all. Okay, that's the assumption here, that we don't need any, that will not use any explicit feedback from the user. Okay, so this is called blind relevance feedback or pseudo relevance feedback. It's a very common method for query expansion. Type. What is the advantage of that? Yes. Yes, we will not ask the user. That's the main advantage, right? We will not wait for feedback from the user. Yes. You think so? So the user, you mean the user will understand? Uh-huh. So are you referring to the problem that we mentioned for explicit feedback? So you are saying that we don't have this problem here? Do you think so? You agree with Mariam that we don't have this problem here? Why is that different from the issue earlier? Still, the system, the user will see results based on the modified query that he or she didn't actually enter. So we still have this problem here, Mariam. It was not resolved. So that might be still a disadvantage for that method. Oh, you mentioned the first one already, right? You mentioned the first advantage, right? Okay. Replying. Yes, so it will be more severe now because it's based on automated feedback. It's not even based on explicit feedback. So it will be more severe. You're right. Is there any other advantage for that? So we said that we will not annoy the user by asking for feedback. What else? How about efficiency? Would that be efficient compared to explicit feedback? Yes, of course, it would be faster, right? Because we will not wait for any feedback from the user. Yes, we have something. Is that guaranteed? Now, this is all based on whether the assumption that the top retrieved documents are actually relevant or not. If they are relevant, then this would be great, right? Because probably we'll get better query and thus better or more relevant documents in the second batch, in the second ranked list. But if the assumption is wrong, then this is clearly query drift, right? Automated, and even without the involvement of the user. Okay, so it will be completely drifted into a different direction, and the user will not get good results. So that can happen. That can happen. Okay, so that's the risk. Okay, so that's actually the biggest disadvantage. That with explicit feedback, if the assumption is wrong, then most probably the query will be completely drifted, and you will get even worse results than the first ranked list. Okay? Any question? Any comment? Yes. What is the scenario? Okay, good question. What do you think? What is the scenario when the blind relevance feedback is really good? Huh? What is the scenario? And when should we use it? Right? Yeah. When can we get benefit from that? Yes. Yeah, but I think Watak is referring to the fact that it is risky, and sometimes we will get bad results. Okay, so I think that you are referring to that, right? So should we use it actually, or is there any use case for it? The standard way of doing blind relevance feedback is that you will not show the user the intermediate results. You will show the user only the results from the modified query. The second round, yes. So usually this method is good if you care much about improving recall. Okay? If your problem needs really high recall, then you should expand the query somehow, and this is one way of doing automated query expansion. Okay? But it might degrade precision, of course. It might degrade precision, but the recall probably will increase. And based on experiments that I saw, on average, it improves effectiveness. On average. That doesn't mean that on every query, of course. Some queries will be really degraded, but on average, it improves performance. But the biggest disadvantage here, and since it's generally on average it improves, then maybe you should use it always, right? Because on average, it will be better than not using it. What is the biggest disadvantage here in blind relevance feedback? Even if I told you on average, it will give better results. What is the biggest disadvantage? Huh? Well, I resolved this issue. I said on average, it's better. Okay, so it's not about effectiveness. Yes, of course you will face in some queries you will face bad results, but on average it will give you good results. So what is the biggest problem now? Yes. Okay, this is already accounted for when we said that on average it will be good. On average it will be good means that some queries will be bad, some queries will be good, but overall, if you measure the performance, the average performance of the system, generally based on the experiments that were done on different collections, it is better. But there is a big disadvantage here. What is the biggest disadvantage? Muhammad?
Yeah, I'd assume that like whenever the lookup query cannot handle or cannot sustain the fact that the worst case scenario can happen. For example, like legal documents, and you are required to retrieve exactly what the user has inquired, not what is the modified query or the expanded query would retrieve. And I assume that's a case where these extra documents that happen to be irrelevant or not effective to the user are very much more detrimental than the average case.
You are again, Muhammad, talking about individual queries. Forget about individual queries. خلاص. We said that on average, the performance will be better. The effectiveness will be better. Okay?
Yeah, but the argument is that it's not on the average anymore. It's because in these given instances where the worst case scenario can occur, such systems cannot tolerate such
Yes,
cases.
Muhammad. Yes. But let's assume that on average, I'm okay with the quality of the results. Okay, let's get out of this. خلاص, we know that for some queries it might be very bad. Some queries might be a bit bad. Okay, for some queries it will be very good. On average, it will be better than not doing it. Okay, with that assumption, with that assumption, what is the problem? طيبة? You mean in the problem for understanding the documents? Okay, so you're referring of the problem of understanding the documents, understanding why these documents were retrieved. Okay, yes, this is still a problem, but there is a even more severe problem than that. Khawla? We are not? But that's the same concept like explicit feedback. And it's just the assumption that might be good or bad, but yes. Okay, but forget about effectiveness now. I told you that on average the effectiveness is not bad. It's even better than not doing it. What is the major problem? Type. What are we doing? Let's compare this with not doing it at all. Okay, what is the biggest difference? Yes, the time. Maybe the time. Why do you think it's the time? Why? Why? Still, that's query and that's. Yes, that's the main point. Here we issue two queries. The initial query and the modified query, right? Don't compare that with the explicit feedback. Because in the explicit feedback, the user gets results from one query and then gets feedback and then gets another results. So the user was involved in the process and it's not one long time, okay? But here, the response time will be much longer than issuing just one query, because these are two queries. Okay, and even the second query will be a bit longer than the first one, so it will take longer time. So that's the biggest disadvantage here. Okay, because response time for search engines is very important. And imagine that you will stay, مثلا, 3 or 4 seconds, not hours even, or not minutes, just 3 or 4 seconds. Every time you write a query to Google, you wait for 5 or 6 seconds or 10 seconds. That's a lot, right? Usually the time that you will really feel when it gets more than 100 milliseconds. Within 100 milliseconds, you will not feel that there is any delay. But beyond 100 milliseconds, you will feel it. Okay. And of course, with blind relevance feedback, issuing 2 queries, that might be a problem. Okay, so that's the biggest disadvantage of blind relevance feedback, in addition to what we already mentioned. Any question about this? Is that clear? Yes. Higher? Yes. Yes, exactly. Yeah. So that's a trade-off. Okay, so I think let me make sure that we covered all of what I have here. I told you that it was proven to be useful in many applications. One of them that I experimented with already personally is the social media search. if we are talking about search in Twitter, for example, query expansion using the blind relevance feedback is much better than using initial query. And you need to think about why is that specifically for that application. Okay. With blind relevance feedback, usually it is just one iteration, one round. Okay, because you are not getting explicit feedback from the user. If you do a second round based on the first one, most probably you will be completely drifted. Okay, so you don't want to make this very high risk. Okay, so blind relevance feedback is usually done with just one round, not more than that. But theoretically, you can do it with multiple rounds, of course, right? So you can get the modified query, get the results, assume the top are relevant, and do the same and again. But usually we don't do that because the risk is much higher when you add more rounds. And of course efficiency, yes. Of course efficiency, yeah. But as I say here, pseudo relevance feedback or blind relevance feedback is one of the very common query expansion methods, especially that it's unsupervised. We don't need any labels to do them, and it's also language independent. It doesn't depend on any language. It's just a technique that just depends on the system output. It doesn't. It's not specific for a specific language. And we talked about, of course, efficiency issue. Now, since we talked about these two extremes, of course, there is one that is in between, okay, which is the implicit feedback, and we mentioned that earlier. So, in implicit feedback, with implicit feedback, you don't get to ask the user explicitly for giving you feedback, but you try to observe how the user is interacting with the system. Yes. Yes. Good question. Do we use the same, assuming that you are referring to Rokio here, do we use the same equation that we used in explicit feedback? What do you think? So what do you think? We can use the same, right? Okay, exactly the same? Remove. What do you mean by remove? Why should we remove the last part? Yes, because we don't use the negative. We just assume that the top are positive, and we don't assume anything about the negative. Okay, so the weight for the non-relevant part will be what? 0. Any other questions? So again, in implicit feedback, you just get some observations from the user. Like what? Clicking. Okay. So with clicking, what can we get from clicking? The relevant document. So when we click on a document, we can assume that it's relevant, right? Does that happen with you? Whenever you click on a document, it is relevant? Okay, so it's not very straightforward like that, right? So you started to think about it now. When I asked you explicitly, you started to think about it. It's not the case that whenever we click on a document, that it's relevant. Actually, it happens many times that when we click to check whether it's relevant or not, whether that will satisfy our need or not. So this signal is not very reliable if you think that clicking will be relevant, but maybe when one case of thinking that clicking will be relevant, if that repeats with many users, okay, for the same query. Can that happen? that many users are writing or issuing the same query? Of course, happens all the time. Okay, all the time. Some queries are issued by many users probably at the same time or different times. So if we have these logs, we call them query logs. Okay, what are the queries that the users are issuing and which documents are clicked? If we notice, system notice that this document is frequently clicked, especially if it's the first one, because the first one should be the highest, with the highest probability that it's relevant. If it's clicked a lot, that might indicate relevance. What else for clicking in particular? We'll get back. We'll get to other signals, but with clicking, what else we can get out of click-through data?
Is it safe to say that if you ignore a link is also like an implicit negative as an irrelevant?
Okay, when can we say that? And when can you say that this document is relevant, or can we can consider it non-relevant?
If the user ignores it.
How do you know that the user ignored it?
By going to some other document below the list.
Very good. Okay, that's the point. Because I assume usually that the user will go from the top to the bottom, right? So if the user clicked on the first one, skipped the second, and clicked on the third, most probably the second is non-relevant. Okay, so that can be also seen as negative feedback. Okay, type. What else other than click-through data? Yes, what else? Get to him and then get back to him. What's it? The time. Time of what? Yani you clicked on one document and then in few seconds you clicked on another one. Yeah, so yes. Okay, so what if the difference in time was really long? Yani an hour. The first one was relevant. Okay. What happens when you get a phone call when you are looking at a document? Okay, can we differentiate between these two? Can we know whether you're actually looking at the document or not? How? Scrolling. Okay, so scrolling is also an implicit feedback signal. Okay, I think now you understand why there are plugins that are attached to the browser to see your activity. What else? What else to know from whether you are actually looking at the document or not? Downloading the document, printing the document. Okay. What else? Bookmarking the document. Okay. Yes. Okay, how can we get implicit feedback from that? That will be that. Okay, the history of the user queries, okay, can help on query expansion, as we will mention later. Yes, okay, but it's not. I don't see it as an implicit feedback here, but it can be used in query expansion. But how about eye tracking? Did you hear about eye tracking? Do you know that your camera can be used to track your eye and know where you are actually looking at the screen? Huh?
It needs permission.
Okay, we talked about this before, right?
And we always lost the
You agree always on the 673 page agreement that you say agree, right? Okay, so forget about that. Yani, regardless of this, it can happen, right? So there are many eye tracking, of course, devices now, and there are many experiments that actually show that with eye tracking, I can see exactly where you are looking at, and based on that, the system can get some implicit feedback. Okay. Yes.
User profile.
What?
User profile.
User profile. I think this is something like what Ahram mentioned. Unless you are talking about something other than the history of the queries.
User profile, that's when I look in, for example, to Gmail, so I have basic information about the user, so I can predict what he is interested.
Okay, so it's not only about queries, yani. Looking at all your data, including your emails. Yeah, again, that can be used for query expansion, or can be also used, I think, we might talk about that later in the course, not 100% sure, to display ads, of course, but that's a different story. Sorry?
Sometimes you feel that they are listening to you what you are talking.
You feel, just feeling, yeah. Okay. It's just feeling. Sometimes you feel that it knows you better than yourself. Okay. Anyway, so you got an idea of what kind of implicit feedback we can use. And this is something that is, of course, less reliable than explicit. Okay, because explicit is explicit, right? You know for sure that the user thinks that this is relevant and this is not. Here you need to do some predictions. But with aggregation, if you were talking about a web search company, in aggregation you have lots of implicit feedback that you can get, and you might get even better results. But for sure it's more useful than, or not for sure, generally it's more useful than blind relevance feedback. Okay. Then why should we use blind relevance feedback if that's the case? If we know that it will be more useful, yes.
If you don't have,
yes, we assume that we have access to all of this information, right? If you don't have access to that information, then blind relevance feedback will be your target. Yes, of course, there are studies all over the place. Okay, any question about relevance feedback? Because we'll switch now to query expansion. Yes, what? Yes. It is realistic if the user needs it. If the user is aware that the system can provide such a feature, and it will most probably result in improving the documents that the user will get, he or she might be willing to use it. Okay. Yes, sometimes it's practical. If you really need more documents and you are not seeing good documents in your first round, you might be willing to give that feedback so that you get better documents. Maybe not the average user. The average user might not be even aware that that can happen, or maybe will be too lazy to do it. But for some users who need really more relevant documents, that will be good for them. Yes, and this is implicit when we talk about implicit feedback. Yes, implicit feedback, when we collect all of this information, it's not only about this query, of course. Yeah, it can be used for other queries, for other users. Yes, sure. Yes. I thought that you were talking about one specific user, but yes, implicit feedback can be used, of course, for generally to improve even the retrieval model, even to train new retrieval models based on that. But blind relevance feedback is limited. It's just for this query, we'll get new results. Any other questions I have? Everything is clear? Okay. Now let's switch to query expansion. Of course, we talked already about query expansion, right? Relevance feedback is kind of query expansion. Some types of it is not automated query expansion, but it is generally expanding the query. And when we say query expansion, that means that we will add new terms to the query. Okay. There are other related problems like query reformulation. Okay, which means that you might actually remove some of the terms. It might happen, by the way, in query expansion also, but query reformulation means that you probably want to keep the size of the query, but you just need to tweak it a bit. You change some of the terms, you add others, but you probably will keep the size, the same size length of the query. Okay, query expansion will expand the query with maybe the length of the new query will be usually longer than the initial query. So it's a related problem, but it's not exactly. There's also a problem called query suggestion, okay? And we see that when we search Google, sometimes there are other queries that are suggested that are related to your query. Here, it's not. You cannot consider it query expansion because we are not adding terms. It's might be completely different query with completely different terms. Okay, alhamdulillah. I don't know how we live with this noise. Anyway, and why it's off now? And what happened, Jens? Huh? It's time to leave? يعني the person who is running the AC? Okay, finishing his job now. Okay. Shift, it's another shift. Type. Anyway, so did you understand now the difference between query expansion, query reformulation, and query suggestion? Okay? So query suggestion is completely alternative queries. It might not have any term from the initial query. It's completely different, but they are related queries. Anyway, now focusing on query expansion. So the goal, of course, is to improve effectiveness by finding related terms and adding them to the query. The method of relevance feedback, as we said, we have different types. The explicit one is not fully automated, but it's called semi-automated, right? Because part of it is automated, part of it involves the user. And there are also automated methods like blind relevance feedback, and we'll talk about more in the rest of the lecture. Okay. Have you heard about this word before, Thesaurus? Anyone knows what we mean by Thesaurus? Yes? So what is it? Yeah, it's a resource that tells you, given this word, what are the similar words or synonyms, okay? What are the related words, okay? So that's like something like dictionary, okay? That tells you that this word has maybe different meanings, or these words have other words that have the same meaning, okay? Things like that. You can think of using something like that for expansion, right? Right? So if I have query XY, I might find synonyms of X, I add them. And synonyms of Y, I add them, right? I can do that. Type. Why here we say that generally it's not effective. What's the problem with that? Of course, we can do that. And in some domains, they work, okay? But generally, they are not very effective. Why? Why could be the reason? What could be the reason here? Yeah, what's the problem with that? That look at a dictionary and just get some of the related words from the dictionary. What could be the problem with this? Yes. Why could we that drift the query? Exactly. Okay, so the context is not there. Okay, and those words are generally related, but sometimes the query has a context, right? It's in specific meaning. It has specific meaning. Okay, that might be drifted if we do this general expansion with Thesaurus. What else? I will tell you one other issue with that. It's hard to maintain updated Thesaurus because over time we have new terms, right, and new meanings of existing terms, new usages of terms, right. To use this effectively, we need to keep updating this resource. Usually, this is static, and it is really hard to update. Okay, so that's another problem with that. But it is used in some domains. It is really used, but generally it's not very effective. Now we'll switch to another method of query expansion, which is based on term co-occurrence. What do you mean by that? The assumption here is that if two terms co-occur in many documents or tend to appear together, that means that they are related, right? To some extent. And this is our goal in query expansion. The user gave us some terms, and these terms might not exactly match all the relevant documents. Okay? But the relevant documents might have related terms to these terms. So we need to find the related terms to those so that expand the query with them and thus reach those documents. Okay? So this co-occurrence might give us some good related words to add to the query. So that's the main idea here. If two terms tend to co-occur together, then if I find one of them in a query, probably the second will add positively to the query, will match more documents that are relevant to the first one. Okay, so that's the idea here. So we need to do some analysis to get these co-occurrence statistics, right? Where can we get these? We have several resources here. We can get it from the collection that we are searching. And we can analyze the documents in the collection, and we can discover which pairs of terms are related based on this co-occurrence idea. Okay, so we can do that over the entire collection. We can do that also over a large collection of queries. If I am a company and I have the logs of the query logs from millions of users, I can actually compute co-occurrence measures that we will, inshallah, see very soon today on the queries in the query log. Right? That's a very valuable resource actually. Right? Because the queries here are queries, right? This is what the user actually writes as queries. Okay? So the related terms that we will get from the queries will most probably will be more relevant or more related to the other terms than the terms that we can get from the entire collection. We can also do that on the top ranked documents in a result list, and this is very similar to blind relevance feedback, right? Okay, so instead of just using raw queue in blind relevance feedback, we can issue the query, get the top results, and then within these documents we see which terms co-occur with the query terms. Okay, so that's generally the idea. Yes. Yes, of course, you can use, you mean bigrams, for example. Okay, but bigrams, it has to be next to each other, right? But here, co-occurrence doesn't mean that they are subsequent to each other. They can appear in a window. Maybe you can, you can do many things here. It doesn't have to be just subsequent to each other. They can be in the same line, they can be in the same sentence, they can be in the same passage, they can be in the same document. So, you have more control generally than with language models. Yes. Exactly. Yes. Exactly. Yes. Maybe I missed saying it, but thank you for pointing me to that. Yes. Here, with co-occurrence means that they appear in the same context. Okay. And we need that when we do the query expansion. We want to expand the query with terms that relate to the context of the query. Okay? So the assumption here is that if terms appear together in some scope, they tend to be relating to the same context, and thus will be good expansion terms if the others appear in the query. Okay, now let's talk about, so here we talked about the main idea, right? Let's talk about how we can compute co-occurrence. And I want to make this general and just say co-occurrence. And you need to keep in mind that co-occurrence can be defined in different ways, as I mentioned just a few minutes ago. It can be co-occurrence in a sentence, it can be co-occurrence in a paragraph, it can be a co-occurrence on a line, it can be co-occurrence on a document, the whole document. Okay? We don't care about that now. Just keep in mind that the definition will give us different statistics if we apply them. Okay? But let's assume that now we have a scope, specific window, where we will compute the co-occurrence within. Okay? Which means that we will indicate that two terms co-occur with each other within this window, within this scope. Okay? Without specifying exactly what this window is. It can be anything based on your domain. So now let's go through, I think, 3 or 4 measures. We'll not go deep into them. They are just formulas, but we'll just get the idea of them. The first one, which is very common, called Dice coefficient. So what are we doing here? We're trying to characterize, we're trying to give a score that tells us whether two terms are related to each other or not based on co-occurrence. So the first one is Dice coefficient. It is computed this way. NAB means, so here we are talking about two terms, A and B. Okay, so this is scoring pairs of terms. Okay. NAB means the number of windows. Let's call it generally a window. Okay, we have a window specified somehow. Number of windows where A and B co-occur together in the entire collection. Here we're talking about a collection of documents. You can apply that on any pair. Yes. This assumes that you will do it on every pair, of course. How you do it in implementation, that's a different story. Which pairs to look at? It depends on your window. If your window is a document, then every pair of words in the document, you will have to compute the score for them. But on the entire collection, using the entire collection. No, it's not a language model. It's not a language. It's different from language model. It's computed in different ways. No, it doesn't have to be each other. It doesn't have to be after each other. Didn't we discuss today in the special session the window operator? Do you understand how it works? This is very similar, right? But only on pair of words. So within, if you specify the window, let's say that the window is 20 words. Okay? Then within 20 words, you will assume that these two words co-occur with each other. Okay, so let's now normalize the definition of the window and just focus on the measures. Okay, so that measure is computed as follows. NAB is the number of windows in which A and B co-occurred. NA in the collection. Okay, we're talking about the entire collection now. NA is the frequency of A. Or number of windows in which A appeared, or number of documents in which A appeared, if the window is a document. Maybe it's easier to just think about documents now. Okay? Maybe let's think about documents, okay, as the window that we are talking about. So NAB will be the number of documents in which A and B appeared together. And NA is the number of documents in which A appeared, and B is the number of NB is the number of documents in which B appeared. But you understand that document can be replaced with any general window. And that's the ratio, okay? NAB over NA plus NB. Right, let's try to understand this. What is NA plus NB? Number of documents of this and that, right? Or that, okay? Type. And what is NAB? It's like ANDing, right? Okay? So this is similar to something that we discussed earlier in the course. Jacquard, yes. Intersection over union. Okay? If these two terms are really related to each other, then what should we get here? You will see that NA is equal to NB is equal to NAB. That's the extreme case. If they only appear together, then all of these three numbers will be the same, right? That's why actually you have 2 here, so that the number will be 1. But this 2 is ignored when we rank the pairs. Okay? So in extreme case, we'll get very high score if they tend to appear together. Now, if they actually don't appear together much, then NAB will be much less than NA and NB, right? So you will get a very low score. That's the intuition behind this coefficient. Okay? Type. If we compute that for every score, for every pair, how can we use it for query expansion? Yes. Higher scores? Yes. Type. Let's say my favorite query, Qatar University. Okay. Let's say that we have Qatar University query. What should we do to expand this query? No, I have Qatar University query. I already have that query. I want to expand it. How can I use this method to do the expansion? I want to make sure that you understand the context that we are talking about. Okay? You understood the measure now, right? Okay, how can I use it for query expansion? Think about this method now. Yani, really? We think about Qatar and University? How can we use the score of Qatar University to expand the query of Qatar University? That's exactly why I'm asking this question. I want you to really think about what we are doing. Okay? Type. This measure can be computed for every pair, right? For any pair of words, right? So we can do that online or offline? Or we should do that offline, of course, right? So we're going through the collection, we can compute these statistics, right? Right? With me, Oman? Okay, type. We have this already computed for every pair in the collection. Now I get the query Qatar only, بلاش university. Qatar only. I only have Qatar. I want to expand this query. How can I use this to expand the query Qatar? Yes. Yes. Already computed. We know them already. Very good. So I will get the scores of all pairs that have Qatar and X, Qatar and Y, Qatar and Z, Qatar and University, Qatar and Doha, any other words. And what should I do? Yeah, I rank them, and I pick the top ones, right? 1 or 2, whatever, but it's like a parameter. Okay? Why is that? Because the top ones most probably are related to Qatar, right? The co-curve, that's the meaning of the measure, right? Or any measure, by the way. It's not only about dice coefficient. Okay? It's also with all the other 3 measures that we will see. But that's the main idea. We rank all the words and then pick the ones that are related to that word and add them to the quiz. Okay. There is a question here first. So, yes. What do you think? Do you mean to compute this?
Yeah, we want to compute how each two terms are related to each other.
Yes.
Do we calculate for each document?
What do you for each document?
No, I mean for all documents.
For or from? From. Okay. Yes, of course. Yes, of course. NAB is the number, if we are thinking that the window is the document, is the number of documents in the collection in which A and B appear together. So you have to go through the entire collection. Okay. Of course, we need to do that efficiently, but that's not our issue now. Okay. Let's assume that going through the collection, we computed this statistic for every pair. Okay. Now, when we get a query term, we get all the pairs that co-occur with it, rank their scores, rank them based on the scores, whatever the measure that we are using, and consider the top for expansion. So that's the basic idea here for query expansion. Okay? Yes?
This is one of my questions. How I choose A and B. So A, I will take it from the initial query that the user used.
So you're still missing the idea here.
No, okay, I did it. I did this one. I went to Qatar. From where I did Qatar, I got it
From the query. The query is Qatar.
from the initial query.
Not initial. Yes, from the given query, yes. Yes.
And I will look for all pair words with Qatar.
Yes.
And I will choose an expand.
Yes.
So if I Qatar CIS, this is my query.
Yes.
CIS Doha. So
Yes.
I will go pick the first one, do this, find which related pairs, and start the Qatar.
Let's say that you will select one for each query term.
Yes.
So you will, for each query term, you get all the words that co-occurred with that query term, rank them based on their scores with Qatar, with the query term, and then add the top one, and then switch to the next one, add the top one, and so on. Yeah. That's the basic idea. Okay. Any question about this? Type. So that's one of the coefficients. We have 3 more. We'll not spend much time on that because they are just different ways of, or different ideas of computing co-occurrence. This one is also common, which is called mutual information. So in mutual information, we want to get the ratio of the probability of seeing both together over the probability of seeing both if they are independent. If they are independent, you need the score to be lower, right? Oh. What do you mean by independent? Independent means that they really appear just by chance. If they appear by chance, but they are actually independent. They don't depend on each other. Okay, co-occurrence is a kind of indication of dependence, right? So here the idea is that I want to get the ratio of probability of seeing them over the probability of seeing them assuming that they are independent. The probability of seeing them is NAB over the number of documents in the collection, which is N capital. And if we do that here, forget about this, okay? Forget about this part. What is B, P, A, and B? What's the probability of seeing both together? It's the number of documents that we see, in which we see both together, which is NAB, over the total number of documents, right? Which is N capital. Type. What is PB? NB over N capital. What's PA? NA over N capital. Now, when I multiply them like that, that's the probability of them being independent, right? Because if P of A and B equals P of A times P of B, if A and B are independent, right? That's the independence rule in probability, okay? So if that's the case, then this ratio will be what? And if A and B are independent, what will be that ratio? 1, right? And log 1 is 0. That's what we want, right? If they are independent, we get very low score. Okay, that's why we are taking the log here. If you do this expansion, then you will get this. Okay, which is N times NAB over NA times NB. And this is equivalent in ranking to just this part, because this is log N plus log this part, right? Log N is constant, so it will not change the ranking, and taking the log itself will not change the ranking, so it will be just NAB over NA times NB. This is different from the dice coefficient, right? Yeah, this is multiplication, this is addition. Okay, I will leave this for you. It says that this favors low frequency terms. What does that mean? That means that if the two terms are having low frequency, they don't appear too many in the collection, this score will tend to be high even if they are actually independent. Okay? So it favors low frequent terms. I want you to check why is that. There are other ways of doing it. This is very similar to the mutual information, but it's the expected number. Okay, so we multiply this, which is the same mutual information. If you look at this, this is exactly MI, but multiplied by the probability of A and B just to get a number. Okay, the expected number of occurrence if they are dependent. Okay, so eventually it will be equivalent to in ranking to this one. So these are different formulas. There is no one that is always better than the others. Okay, so you just use one of them, or actually experiment with them to see which one will be better for your domain, for your collection and your problem. A fourth one, which is really common, called chi-square measure. I don't know if any of you came across one of these before. No?
I used that at work, chi-squared.
You use chi-squared? Okay. So chi-squared it compares the number of co-occurrence of two terms with the expected number if they are independent. So NAB is the number of the actual co-occurrence. Okay? This one is the number if the expected number of co-occurrence if they are independent. Okay, so if these two, if actually they are independent, then this numerator will be 0. But if they are not, then this would be higher. And it's normalized by the expected number if they are independent. So that's another formula here. That's the chi-square measure. But all of them have the same or similar concept. Higher value if the terms tend to co-occur together and tend to be dependent, and lower, very low value if they tend to be independent. If they are just co-occur by chance, but they are actually not related based on co-occurrence.
So, Doctor?
Yes, Muhammad?
So just to confirm, that means they all converge to the same analysis, right?
No,
So
no,
it
no,
doesn't
no,
matter
no.
which
They are
one
not
I
the
choose.
same. They're not exactly the same.
No, but in
But
because
the
usually,
same
like for
concept.
example,
Similar concept.
like for example, at work we can either use chi-squared or like I forgot what was the
Yeah,
other one
in
called,
terms
like,
of usage, you can use any of them. Okay?
Yes.
All of them are, as you see, all of them are a function of 3 numbers.
The question was like, if for example one gave us like a specific value, like is it safe to assume that the others will return the same outcome?
No,
As in, like,
no. Otherwise, we
Not-
wouldn't say that there are 4 different measures. They don't usually get or give you the same results. Okay? So you can experiment with different measures in with different collections to see which one will be better for your purpose. Okay. Any question about this co-occurrence measures? The most important point here is for me to understand, for me to make sure that you understand how we use this. All of them, as I said, all of them are a function of 3 numbers. The number of scopes or windows or documents in which 2 terms appear, and the number for each one separately. But just different ways of, different functions of these 3 numbers. But I want to make sure that you understand how we use them. Any of them. You take you take the query, you get the terms from the query. For each term, you see which one, which terms co-occur with that, and you add it to the query. Of course, this has a problem if we do it this way. This is the basic idea, okay? But that's not the best way to do it. This has a problem, and with that we'll start, inshallah, next week.